is type of material or type of steel for bolt or for connected material. Did you get the question?
Yes.
We have material for blades, or this material or this element or these members called connected members. And this bolt called fastener or bolts. This material for these members has F yield and F ultimate different than material for your bolt. Your bolt has F yield and F ultimate. You are talking about material properties for connected member or material properties for your fastener or your bolts. Which material properties I will use?
Material.
If you are talking about failure in the fastener, we are talking about material properties for the bolt. If you are talking about this kind of failure, tearing behind the last fastener, or bearing in the material for members in connection, you are talking about material properties for the connected members. You got it? So right now, I'm talking about mode of failure, this one. So you are talking about material properties for steel for the connected members. Double angle, single angle, channel, or something like this.
Yeah, because those bolts have grade too, right? Like steel
Yeah,
grade.
yeah, different too, different material. Okay, so 1.2 F ultimate LC time T. Okay, I understand what is the value of F ultimate right now. What's LC? LC is the edge distance between the edge of the hole and the edge of your member. So LC, distance from edge of the hole to edge of the connected part. T, thickness of the steel blade, thickness. If you are talking about angle, thickness of your leg. If you are talking about blade, thickness of your blade. To avoid, so the first equation, which is Rn equal 1.2 F ultimate LC T, that's right? To avoid tearing for the last part this area, tearing. We need to avoid any excessive elongation. Excessive elongation, this blade is pulled in this direction. So we have bearing between your bolt and this area of your member. So we can expect bearing failure at this location. To avoid this bearing, the nominal resistance equals C time bearing area time F ultimate. You can make it C time D time T time F ultimate. C is a constant. You can't get it 2.4 according to AISC. D, diameter of your bolt. D, diameter of the bolt. T, thickness of the connected bar. One more time. F ultimate here, material properties for the bolt or the connected material. Connected material. Until now, I'm talking about two kinds of failure. tearing or bearing failure. One more time. I'm talking about these two modes of failure. Tearing for this little part behind your bolt, or bearing. We don't have tearing or shear off, but only we have excessive deformation in this area around the hole, like this. This is called bearing failure. Nothing teared or nothing sheared off, but we have excessive deformation in the hole. We need to avoid this one. We need to avoid this one. That means your resistance or nominal resistance of your connection may be equal. This term to avoid tearing, or this one to avoid bearing, according to AISC. As I told you, hey, you have a member, you have different location in your member. The member itself can support a number. The connection can support another number. Maybe different kind of connection can support another number. So finally, your design or your nominal resistance of your member will be the weakest number or the smallest number. One more time. LC is the distance between the edge of the hole to the edge of your member. T thickness, D diameter, T thickness, F ultimate here or F ultimate here will be material properties for the connected member. We have some notes here. If you would like to calculate LC, LC equal LE minus H divide 2. H equal diameter of bolt plus 1/16 only. So we have something called B, diameter of bolt, add 1/16 to this diameter to get something called H, which called hole diameter. If you can divide this whole diameter by 2, subtract this number from distance from center line to the edge, you can get the distance from the edge to the edge. So most of the time, this distance is given. Distance from center line of the hole to the edge of your member. Subtract H divide 2 from this distance, you can get your edge distance LC. H divide 2 equal, H equal diameter of bolt plus 1/16 for the additional to make clearance around your bolt. So when computing the distance LC, use the actual hole diameter, which is 1/16 inch larger than the bolt diameter.
Why don't we use 1/8? You remember how you used to say 1/16 for the thing to enter, and then it would also say.
I don't care about any damage or any additional damage around this hole. I need only the actual diameter of your hole. The actual hole diameter equal your bolt diameter plus 1/16. Maybe to calculate your net area, you can add another 1/16 for the additional damage in material. But you still have material, but damaged material, I don't care. Okay? So right now I need what is the hole in this area, diameter of bolt plus 1/16 to make clearance around the bolt. So let's try one example, but before any example, we don't use nominal resistance. All the time we are using design resistance by adding a resistance factor called phi. In this case, your phi equal 0.75. One more thing before starting. Until now, we didn't learn how to find the number of bolts. Until now, we have a connection with bolts, and we need to get the resistance to avoid any kind of mode of failure. Next time, or next lecture, we will talk about how can I calculate the number of bolts, the required number of bolts. Anyway, to maintain clearance between bolt nuts and to provide room for wrench sockets for each bolt, the distance between hole or bolt center to center, which called S, must be no less than 2 2/3 diameter of bolt. Most of the time, we would like to take it 3D or 3 let's say D. D diameter of bolt. Different diameter of bolt available, maybe 1 inch, half inch, 6/8 inch, 3/4 inch, 7/8, 1 inch, 1 1/8, 1 1/4, maybe over 1 1/4. Here is the available diameter of the bolt. If you selected your diameter 3/4, okay, multiply 3/4 by 3. This is the minimum distance between bolt and bolt center line to center line. So EISC requires that center to center spacing of fastener in any direction. If you have bolts here, the center line to center line, center line to center line, be no less than 2 2/3 diameter. We prefer 3 diameter, where D is the fastener diameter. I'm talking about center line to center line of each bolt. We have another distance between center line of the last bolt and the edge of your member. This distance, which is called LE. LE based on this table, minimum edge distance. If your diameter of bolt 1/2, your edge distance must be 3/4 inch. This distance must be 3/4 inch. If your diameter is 1/2. If your diameter is 6/8 inch, your minimum edge distance from center line of the last bolt to the edge equal 7/8. If your diameter 3/4, your last distance must be 1. So arrangement of your bolts, we need to follow. What is the minimum distance center line to center line? What is the minimum distance from the center line of the last hole and the edge? Do you remember when you are designing your tension member? Anybody remember? We have something called area effective, which equal U times area net. Do you remember? U equal 1 minus X bar divide L. Many students asked what is the value of L. I told you L is the distance between the first bolt to the edge. That's right. We have an example or problem in the homework, L not given. L sometimes not given. I think right now you can calculate L, because the distance between this one and this one will be 3 diameter. And the distance between the last one and the edge based on what is the diameter. If you know the diameter of your bolt, I can figure out what is this distance, what is this distance. Based on the diameter of your bolt, I can figure out what is the edge distance, add them together to get the distance L that can be used in this one to calculate your effective area. Also, I still saying we didn't learn how to calculate how many bolts. It's very important. I have a member in my truss, and I know the tension force in this member. How many bolts I need? We will learn all of this stuff next time. But right now, we have a given bolt, a given connection, and we need to figure out what is their design strengths. Check, just to check. Bolt spacing, edge distance, and bearing for connection. Do you think this distance from center line to center line is good? Do you think the edge distance between the center line of the last bolt and the edge is good? Do you think the bearing for this given connection is good? We need to check. Okay. Minimum spacing between bolts, center line to center line, which called S. What is the value? 2 and 2/3 your diameter. That's right? We prefer to be 3, but let's try the minimum one. So 2.67 times diameter of your bolt. I think your diameter is given 3/4 inch diameter bolts. So time 3/4 inch. What is the value?
Just over 2.
Yeah, 2 inch. More, 2 inch. The given distance between center line to center line for this connection, 2.5. You are okay or not okay? I'm okay. This is the minimum. Yeah, I can exceed this value, but I cannot below or behind this value. Okay, what about the edge? Minimum distance for your edge distance. I think we don't have expressions, we don't have equation, but we have a table. Your diameter of your ball, 3/4. From this table, 3/4 diameter, the edge distance, the minimum edge distance equal what? 1 inch. So go back to your connection. The edge minimum must be 1 inch or greater. Your edge distance between center line